Assalamu alaikum. Myself Dr. Ansari Farzana, Sama, Department of Chemistry, J.A.T.rts Science and Commerce College, Malegaon. Welcome all of you. Now today we shall discuss about dissociation constant of weak electrolyte. The strength of weak electrolyte is directly estimated from the magnitude of dissociation constant. The dissociation constant of weak electrolyte is determined from the equation of Ostwald dilution law. K is equal to C alpha square upon 1 minus alpha, where K is dissociation constant, C is the concentration of electrolyte, and alpha is the degree of dissociation. Conductometric acid-base titration. A known volume of the acid is taken in the conductivity cell. The base of known strength is added from burette in a small quantity, and conductance of the solution is measured after each addition. Consider the titration involving a strong acid and a strong base. Suppose that a solution of hydrochloric acid is to be titrated against a solution of sodium hydroxide of known strength. The reaction is HCl plus NaOH. It gives NaCl plus water. This is the titration curve between a strong acid and a strong base. From the graph, it is observed that initially conductance of acid solution is high due to the presence of high mobility H plus ion in the solution. As the titration progresses, these ions are replaced by Na plus ion of low mobility. As a result, the conductance of solution falls. After the end point, the conductance of solution increases due to introduction of OH minus ion, in which arises from unreacted sodium hydroxide. The point of intersection of two lines gives the end point. Now consider the titration between a strong acid and weak base. Suppose the hydrochloric acid is taken in conductivity cell. Solution of ammonium hydroxide of known strength is added from burette. The reaction may be HCl plus ammonium hydroxide gives NH4Cl and water. The nature of graph for titration involving acid and strong acid and weak base is shown here. We see that initially high conductance of solution decreases with addition of solution of ammonium hydroxide, as high mobility H plus ion are replaced by low mobility of NH4 plus ion after the equivalent point. However, the conductance of solution does not change markedly with the excess addition of ammonium hydroxide, because the dissociation of ammonium hydroxide, which is in itself is small, is further suppressed by presence of the common ion NH4 plus ion in the solution. Now consider the titration between weak acid and strong base. Suppose that a solution of acetic acid is titrated against a solution of sodium hydroxide. of suppose that a solution of acetic acid is to be titrated against a solution of sodium hydroxide of known strength. Initially, the conductance of solution is low. Formation of sodium acetate during neutralization suppresses the dissociation of weak acid common ion effect, which lowers the conductance of solution. The rise in concentration of the sodium acetate tends to increase the conductance. The combined effect of the two opposing tendencies is that conductance passes through minimum and then increases. The position of minimum depends on the concentration of acid and its dissociation constant. After equivalence point, the conductance increases rapidly due to the presence of OH minus ion with high mobility, and we obtain this type of the graph. Now consider the titration between weak acid and weak base. Consider the titration of acetic acid with ammonium hydroxide. The reaction may be acetic acid plus ammonium hydroxide. It gives ammonium acetate and water. As in this graph, we observe that conductance decreases with addition of ammonium hydroxide and passes through minimum. It is then increases with more and more amount of ammonium acetate, a strong electrolyte being formed at titration proceeds. After equivalence point, the conductance of solution remains almost constant because of a small extent of dissociation of ammonium hydroxide, which is further suppressed by ammonium acetate due to common ion effect. Thank you for watching.